right, good. Okay, welcome to the third session of today. We're going to be covering prompt products. A reminder that there's an exit survey. The exit is actually like the exit from every session. The survey is very anonymous and it's short, just the name of the session, how useful it was, what you learned that was most helpful, and what else would have been helpful, or trying to improve our sessions content for next year. So please do, once the session is over, let us know about it. As a reminder, once you leave the Data Academy, when you have questions or run into problems, the Rubin Community Forum is the place to go. It is our help desk. It's available online at community.lsst.org. It's completely open to everyone, whether or not you have Rubin data rights. And all you do is come here, open up a new topic in the support category, ask your question, and Rubin staff monitor this and follow up and help you solve your problems. All right. We've heard a lot about different types of data products from Data Preview 1 and Data Preview 2. Those two data previews, 1 and 2, they are more like previews of the future annual data releases, like small data releases with similar formats as to what you would get with data release 1, 2, 3, 4, 5, etc. And the annual data releases will have all images ever taken by LSST reprocessed and deeply co-added every year. So it's a reprocessing of all the data we've ever had with the latest versions of the LSST science pipelines, redone and released every year. The annual data releases have catalogs. I've heard a lot about those, various image types, plus things like survey property maps, the PSF information, shear measurements, all of that stuff. So that's annual data releases, and the data previews are like previews of those future annual data releases. But that's not the only kind of data product that Rubin Observatory makes. The prompt products are the other type of data product, and these result from near real-time processing that is done for time domain science. The different types of prompt products that come out of this real-time processing include the alert packets that come out within a few minutes of a new image being obtained by the camera. And alerts are measurements for different image detections that are distributed to alert brokers. Also included in prompt products are catalogs. These are user-facing catalogs that get updated within 24 hours of the new images being taken. And these are also measurements for difference image detections, but instead of being streamed in alert packets out to brokers, they are stored in queryable tables. So for these two types of prompt products, if you're doing time domain science where you want to do sort of follow-up in real time during the night, within a few minutes to within a few hours, or within like a day or two, then alerts and brokers are the data product that you'll want to use so that you're working in real time. If you do work in the time domain, but not, same night kind of information is needed, but maybe you need a database to query every couple of days, every couple of weeks, once a month when you have your follow-up run and you want to look for sources that are interesting to you, then it's the prompt products catalogs, or as we call it, the prompt products database, PPDB, which is updated within 24 hours, but is queryable. That is the data product that you are probably going to be using. And then, of course, the images from which the catalogs and the alerts are made become available after 80 hours. So there is an 80-hour embargo on the full processed images, both the science images and the difference images. There are also different data rights applications to the different prompt products compared to the annual data releases. So in a sense of public versus proprietary, where public means the data product can be shared with anyone, anywhere, worldwide, versus proprietary meaning that it's available to Rubin data rights holders only. The public data products are the alerts and the contents of the prompt catalogs. Those can be shared with anyone, anywhere. Access to the prompt catalogs, because access to the PPDB is only through the Rubin Science platform. Access to the PPDB is still proprietary because the Rubin Science platform is for data rights holders only. But as a Rubin data rights holder, if you're working with the prompt data, you can find objects of interest and share those with anyone you want, because the same data went out, the same information went out as an alert, which is completely world public anyway. So that's what is public in terms of all of these data products. And then proprietary is kind of everything else. The prompt images, the annual data releases are both proprietary to data rights holders for 2 years. And then, as I mentioned, the access to the Rubin Science platform is also proprietary. Prompt products, only a couple are available now, but the rest of them are going to be made available over the course of the year. Our prompt products documentation is at prompt-products.lsst.io. Everything that I'll say here today is also available in the prompt products documentation. And the timeline for doing early science with the first versions of these prompt products are that in February of this year, alerts began streaming to brokers. So they are out now. I'll tell you more about brokers and how to access them in a minute, but that's like the first bit of prompt products that are available. In June, so that was just like a couple of weeks ago, the portal alert viewer and the alert retrieval service in the RSP were deployed. And so this gives data rights holders via the RSP access to single alert retrieval. You can programmatically interact with single alerts in the Rubin Science platform. So that is a new thing, and I'm going to show you how that works today. Later this year, so on a September to October timeframe, the nightly updated prompt products database, these 24-hour refreshed catalogs, should become available. And then looking further in the year on an October to December timescale, the prompt process visit and difference images and direct source catalogs to go with the prompt process visit images should start to become available. To kind of tell the story of what is prompt processing and how it works, this is what I want to cover with this slide. So first off, the acronym DIA is something that you will hear a lot with relation to prompt products and all of the time domain products in general. And it stands for difference image analysis. And how it works, it starts with PSF matching. So a new image comes off the telescope, comes off the camera, and that new image gets all of the regular instrument source removal processing and becomes a processed and calibrated visit image. Then we go to the all sky tessellation of template images. So it's a all sky deep coad with very good seeing template image. And a template image is cut out of that has the same dimensions of the new visit image. And that template is warped and scaled and PSF matched to the visit image. And then the next step is image subtraction, where the template is subtracted from the visit image to create the difference image. So template image, visit image, and difference image are the key terms here. With a side note that the visit image is also sometimes called the science image or the direct image. Science, direct, and visit image all kind of mean the same thing and are used interchangeably. But the difference image is the one that results from the image subtraction. All right, the next steps once this difference image exists is source detection. Positive and negative sources with signal to noise ratio greater than 5 in the difference image count as detected. Measurement is run with PSF fluxes measured for all detections. This goes into the DIA sources table. Then association happens. This newly detected source in a difference image is associated either with a static DIA object. So if we've ever seen a DIA source at that location before, as in at that RA and DEC before, then it gets associated with the DIA object that has been established already at that coordinate. Or if there was nothing there, but there's a known solar system object that's expected to be at that location, at that time when that visit image was taken, then the DIA source gets associated instead with that solar system object. The association radii that are used for both of these cases is 1 arcsecond. After that, characterization happens. So the DIA object has time series features that are measured from the accumulation of detections. So all of the DIA sources, all of the past detections for that particular time domain object in the sky, the supernova, whatever, various features of its light curve are calculated every time a new DIA source is added. So these time series features get recalculated for the associated object. And then the final step for the prompt processing pipeline is alert generation. So each new DIA source, every new signal to noise ratio greater than 5 detection in a difference image, all the information that we know about it, the triggering source, and the associated object or solar system object, it's all packaged up into an AVRO. AVRO is just the format, alert packet, and distributed to brokers. So the product of this real time, which happens within like 2 minutes of a new image coming off the telescope, is the alert packet. And those go out and they are streamed to brokers. The next step in this prompt processing narrative is the update of the prompt products database. So on sort of a within 24 hours time frame, all of the new data that came from this like in real time nightly prompt processing is integrated into the user-facing prompt products database. That's the PPDB. That happens within 24 hours, and it's tables like DIA source, solar system source, DIA object, and solar system object tables. There's also all the daytime minor planet center processing that we heard about in the first session today. And that's where the tracklet linking, new solar system object discovery from the tracklet linking, and then derivations and updating of the orbital parameters by the minor planet center. All of that happens, and that gets cycled back into the prompt products database as well, where the particular table there that's coming from the minor planet center is MPC orb. So the minor planet center orbital table. So that's kind of the story of prompt processing, what is happening to make these various data products. And in particular, the prompt products database, the PPDB, which should become available September to October of this year, will be comprised of these tables. All of these you've just heard about: DIA source that contains the 5 sigma detections in difference image, the DIA object table that has derived parameters for associated detections on the sky. So for the DIA object table, 1 row per unique sky coordinate where we've seen a time domain object, whereas DIA source, it's 1 row per detection. So 1 row per coordinate per time. Force source, actually, I'm not sure this belongs on here in the same way. So let's skip that. I think we do. I mean, force photometry is done, but I meant to remind myself exactly what gets done, because some precovery is done, and then DIA objects that we already know exist from the past that have had detections in the past 12 months. As they fade, force photometry gets done at their locations, and that photometry gets put into the DIA force source table. So for brand new objects, you can go back and you can look up their like 30-day precovery in the DIA force source. And then you can also, if your object has faded below the 5 sigma detection limit, you can still go and get force photometry out of DIA force source. I meant to add exactly the details for what's happening there to this slide, and I forgot, so I'm sorry about that. But there will be some force photometry. And then there's the solar system object source and MPC orb tables that you get. There will also, of course, be observational metadata in the prompt products database. All right, PPDB, all of these names. So if you were in like the difference image session yesterday, a lot of these names are very similar: DIA source, DIA object. They also exist in the annual data releases. Are they exactly the same or not? And they are very similar in terms of their schema, but they're not exactly the same. So the DIA object, for example, the user-facing DIA object table in the PPDB will always update to like the latest version of the DI object. Because if you remember, I mentioned how the new DI source is detected associated with the DI object, and that entire DI object record, all of its values get updated like in real time every time we have a new detection of that object. So when you query the DI object table in the PPDB, it will always be the DI object as its most recent version, but a DI object table with provenance will exist. And what that means is you'll be able to go back in time and get the version of the DI object as it was like a month ago, if you need that kind of thing, which, for example, if you're doing a rates analysis survey, or if you have sort of an ongoing object selection where you need to know exactly like what fraction of objects made it past your particular cuts and made it into your follow-up survey, and you need some provenance there to sort of recreate things as they were at the time when you were making decisions about what to follow up, that table will exist, and we'll have tutorials to help you figure out how to access this giant DI object table with provenance. So that is a difference from the like annual data releases, which are more of a static data release. They don't get updated. They just come out once and then that's their version. But because the PPDB is constantly being updated, there needs to be some provenance on those tables. So that's one example of a difference. The other example is that, as far as I know, both the DI source and the force source tables will no longer be spatially queryable. The correct approach to pull data out of the DI source and force source tables is to do your spatial queries on DI object and then use an ADQL join, or then do a separate query to pull the light curve data out of these tables for a given DI object ID. Doing queries on source and force source tables, especially query ones, is just really ineffective because you've done one spatial query, but then it has to go through every table and effectively do the same query for every single observation that LSST has ever done. So Data Preview 1 was small enough not to need to enforce this no spatial queries on these deep photometry tables. But the prompt products tutorials will demonstrate how to do it. And in fact, if you've been using Data Preview 1 and you've been running queries with DI object and DI source and force source tables to create light curves, that's already the way that we're teaching everything. So if you've been using those tutorials to make your queries, then you're already set up to have this be sort of the default way that you query the tables anyway. Another difference is that the DI object table will have relatively limited time series features, at least at first. So for now and for the short-term future, the only time series features that are being calculated and stored in DI object are the minimum, maximum, mean, sigma of the fluxes of the associated DIA sources, and the slope and the number of detections that a given DI object has had. So that is a smaller number than was in for example, the DP1 DI object table. It's been sort of pulled back a bit so that the prompt products database processing time, DI object processing time, remains low, but then that number of time series features that are going to get recalculated always on the fly is going to grow over time. And there's a data management tech note number 118 that kind of describes the vision for some of the time series features that are going to be added to the prompt processing pipeline over time. One of the other differences between Data Preview 1 and the prompt products database is solar system source rank matching. Okay, so individual DIA sources can have multiple matches to known moving objects within a radius of 1 arcsecond. So remember, this is, you have your difference image, you've detected a DIA source at that location, there is no known static sky source at that location. You look at the known solar system objects, and then you look at which of those were expected to be at that location at that time within a radius of 1 arcsecond. It can happen that there could be 2 known objects that could potentially be matched to that particular detection. One will be closer and the more likely match, that's where the rank comes in. So these multiple potential matches get ranked by their expected distance from where we saw the source detection. And that information about the multiple potential matches and their ranks gets stored in the DA distance rank column of the solar system source table. So that is going to be, as far as I know, a new thing for the prompt products database in terms of solar system objects. All right. Maybe I'll have a little pause there because that was kind of an onslaught and I have more to tell you, but it's a nice little questions pause. Yeah, Tim.
Hey, Melissa. So for this de-scoping of the time series features, I think this makes sense to get it sort of up and running. Is there kind of an idea of the roadmap of what gets added later and when, or see how it goes?
Yeah, I'm not exactly sure if there's like an ordered list of things that the alert production team plans to add over time. I only know what's in data management tech note, which is like the full future like the full future wish list vision. So I don't know actually what's next on their list to add. Is there something in particular that would be most useful?
Not having looked at the big list in a long time, nothing specifically. It was more just a process question. But
Yeah.
that's fine. No problem.
Yeah, I think um our plan had been before to sort of involve the community in the decision when the time came. I think it's just not the time yet to start adding. That's my impression. Not quite the time yet to start adding things in, but probably they'll do a big batch of like the obvious things to add back in. And then if it gets to a case where decisions have to be made, whether we have to add this or that, and it can't be both, then we might come to the community to get some feedback.
Sounds good. There's also a question in the chat for you.
Oh, oh, thank you. Will there be some training scheduled later when DP2 is out, especially with regards to the changes? Yes. So once we know the DP2 release date exactly, we will schedule some onboarding sessions that will happen in the week to weeks after that release date. It kind of depends a lot when that date is going to be. It's the summer now. We have conferences, we have vacations, but there will be some onboarding. There will be plenty of tutorials to help people get started with Data Preview 2. Same for when prompt products come out. And there will also be a suite of tutorials for you to work through at your own pace. More questions while we're paused? All right, let's talk a bit about the prompt processed images. They are expected October to December of this year. They will also be similar to, actually, the slide should probably say similar to DP2, not DP1, because there will be LSSTCAM images and they will be processed with similar pipelines and made available in similar formats as to DP2, not 1. A reminder that all prompt images are subject to the 80-hour embargo. So it's after 80 hours, the full visit and difference images will be made available via the Rubin Science platform. Again, another DP1, DP2 typo. So the third boldface line should say DP2 and prompt visit and difference image availability is later in the year, October to December, due to some bandwidth upgrades that are currently going on. So the DP2 deep coads, this bothers me. Much better. Okay, the DP2 co-added images and all the catalogs and the prompt products database will all be stored in the cloud where it's trivial for you to access it from data.lsst.cloud, cloud to cloud access, easy. Whereas the visit images and the difference images and the RAWs are all stored at the US Data Facility, the USDF. Bandwidth upgrades to support user access from the cloud to the USDF for the visit and difference images are currently underway. And so that is why DP2 and prompt visit and difference images will be made available on a later time scale. Another note is that the prompt visit images will be accompanied by a direct source table, where remember direct, visit, and science image all kind of refer to the same thing. So the direct source table is the result of source detection being run on the visit images. And until data release 1 is out, a source detection will be run on the individual visit images because LSST will be still covering new areas of sky. So it'll be a region where we get a new visit image, but there's no template, so we can't make a difference image. And if we can't make a difference image, then nothing that's detected in that new area of sky actually makes it into the prompt products database, because the prompt products database is entirely the result of difference image analysis. And so as we are covering new areas of sky, source detection will also be run on the direct images, and that those sources will be stored in accompanying tables that are called the direct source table. After the first data release 1, when all the data is reprocessed and everybody has source and object catalogs for the full sky, it won't be necessary to make these direct source tables anymore. Final note is that the direct source also becomes available after the 80-hour embargo, because they go with the visit images. I will pause here as well for prompt image questions. All right, let's talk about alerts and brokers. So I mentioned before, of the prompt products, alerts are the products that are released within minutes. They are effectively notifications of detected sky changes because they are triggered by a new detection of a GIS source in a difference image. Once LSST is up and running at full fidelity, we expect up to 7 million alerts per night to be distributed to brokers in the full alert stream. And we like this picture because alerts and brokers together kind of represent a community fountain where everybody can come and get their time domain objects of interest from the alert stream and the brokers. As I mentioned before, 1 alert is issued for each difference image source detection with a signal to noise ratio greater than 5. The alert packet itself is just a machine readable file that contains data for the detected source. So it has sky location, like the coordinates of the source, measurements like flux, shape, and size, the observational metadata, the date, the time, the filter of the observation. Comes with a history of past detections up to 12 months and very small image cutouts like you're seeing at the top of the slide here. Reminder alerts are a public data product. The brokers, on the other hand, are independent software systems that process and serve alerts to the science community. They add value to the alerts. They offer filtering, cross-match, classification services, and also data access services. So either through their web-based user interfaces or their API clients. You can find an overview of all of the brokers. There are links to their individual websites, all at rubinobservatory.org in our For Scientists website. And these are the little, what is it called? Logos of the 9 brokers. There are 9 in total, 7 of which we call full stream because they take the full alert stream from the LSST. And then 2 are called downstream. They take a subset of the alerts from one of the other brokers. And usually these 2 downstream brokers, the SNAPS and point of interest. SNAPS is the one for solar system objects, and points of interest is more focused on variable stars. So they have a more specific science focus, which is why they can get by with just a subset of the alert stream. The alert stream, as I mentioned, has been up and running since February 2026. If you'd like to or need to see a real-time status dashboard of the alert stream, it's available at ls.sc/alert stream status. And that's what the screenshot on the left here is of. It's just of whenever I made the slide, like a week ago, this was the status of the alert stream at the time. And then if real-time analysis and using one of the brokers is something that you want to get into, we have been running a whole series of broker tutorials as part of our Rubin Science assemblies, and recordings and slide decks from each of the brokers exists, and you can find them all in the For Scientists web pages of rubinobservatory.org. So you can investigate more about brokers there, find a few, test them out, see if they work for your science. And they all have their own support staff, their own tutorials, super helpful people if brokers are something that you want to get into using. Right now, alert generation is limited by the sky areas that LSST has managed to cover so far and create templates for. The number of alerts and also the sky area covered by templates it's a goal to increase these over time. There is currently a template coverage interactive map that you can get to at this URL. So you can go in, see the sky coverage in the various filters for the Rubin template coverage. And then right here, I'm just showing the number of alerts as a function of time. So you can see when the alerts first started, there was a real focus on pushing lots of alerts through the pipeline. That has dropped off, and the focus became more about engineering up at the summit and getting the image quality ready to start the LSST survey. And now you can see that a number of alerts are coming back online as more and more like pre-LSST type observations are being done up at the summit. So starting to ramp up again, which is really great. All right, I would like to lead you through a couple of tutorials for how to access individual alerts. Before I actually jump in, I'm going to pause for any other questions about prompt products in general, prompt PPDB, prompt images, alerts and brokers, anything like that. All right, let's do some hands-on tutorials. We'll start. I just want to show you the tutorials page in the prompt products documentation. This is where you can find tutorial for the portal aspect and then also some rendered versions of the notebook tutorials. Today, we're going to start with the one portal tutorial that we have called Navigate the Alert Viewer Interface. And for this one, yes, okay. So you've come to data.lsst.cloud. You've entered the portal aspect. This is the main landing page of the portal, which you've seen, I think, probably several times today already. One of these tabs is the alert viewer. And the use case for the alert viewer is, and also for the alert retrieval service that I will show you how to use in the notebook aspect, brokers are the primary interface for all scientific analysis related to alerts. The Rubin Science platform is really not the place to go to find alerts of interest. It doesn't offer filtering services. You can't query the alerts databases. All of that kind of functionality is broker functionality. But here in the RSP, if you have been using a broker and you've been querying, actually, I can just show you. Sorry. Say you're using the Antares broker, for example. This is the Antares broker interface. And say you've been curious about LSST brokers, LSST alerts that have come out within the last month and have, I don't know, at least that many observations. You can also enter a central coordinate if you knew one. Let's see if our simple filter Yeah, so our simple little restriction to look for alerts from the past month from LSST have got us a bunch of them. You might look at some of these and say, oh, wow, that one looks pretty interesting. I want to know more about it. You can click on the Antares page and it will, oh, that's not a very interesting one. And it looks like it's mostly ZTF detections. Oh, here we go. Oh, this is very interesting. Wow, look at that. Okay. Nice variable star here. But for example, in this interface, right now I'm just using a broker's user interface that's browser based. If I actually want to get the light curve, or if I want to get the image stamps for this particular alert, there's an LSST alert ID right here. And now you're in the case where you want to go and look at that alert somewhere else. The portal tutorial uses this particular alert ID. And you can come into the RSP, give the alert viewer the alert ID from wherever you got it from, and load that particular alert, and the data from that packet comes in here. So you can see at upper left, this is the associated DIA object that goes with this particular detection. At upper right, it's plotted not just the particular detection that triggered, but also the entire history of detections of this particular DI object. All of that got shipped with the alert packet. And then along the bottom, it's the image triplet with the science, direct visit, image at left, the template image, and the difference image. And the thing you notice right away is that for this particular object, it is variable with time, but all of the LSST observations, it was fainter in the LSST science image than it was in our template image. And all of the particular DIA source detections of this object are negative. They show up as black in the difference image, and they show up as negative fluxes in this particular light curve. If you want to get at the data for that backs this particular light curve from here, you can switch from chart view to table view. And here, for example, if you're like, want to know more about what the object was like on the night when it was at its very faintest, for example, you'll come into the table for the PSF flux columns. You could sort it by PSF flux. So now its very faintest epoch is up at the top. The DIA source ID is the same as the alert ID. So we could copy this one, this alert ID / DIA source ID, and go back in time and get the alert for the same physical astrophysical object, but back at the time when it was the faintest, and load it then. And you can see the alert packet at this time did have the history, but it was a shorter history because it was at a previous time, also detected as negative, but you can see here now it's a much more strong negative source that was detected because it was even more fainter in the science image than it was in the template image, and some of the same other information there. So with this example, I'm just trying to impress upon you that you can pull up the data in the portal. For one, there is no band selection in the portal. That is true. I mean, you can manipulate this plot up at the right corner, but you're right that, for example, these points really should be color coded by the filter that they're in, and they're not yet. That's a request that we have in, is to make automatically color points by their filter. And that's not true yet. It's a good question, Sylvie. Right, but the point here is that the portal alert viewer, you can pull out one alert at a time. And I just wanted to demonstrate how there can be multiple alert packets go out for the same astrophysical object. And when you're using the most recent one, it will have the entire history. But if you use an older alert packet for the same object, it will only have the history that it had as of that time. questions about the portal alert viewer? All right. So we move into the notebook aspect. So you've come to data.lsst.cloud, log into the notebook aspect. You will find two tutorials under prompt that exist right now. One at the 100 level for the alert archive is all about the alert retrieval service. So all about the tool in the notebook aspect that you use to retrieve single alert packets. And then at the 200 level for alerts, there's one tutorial that describes the content, the format, the schema of the alert packets themselves. I'm not going to go through these in great detail. I will just run all of the cells of the alert retrieval service one. But the point that I wanted to make is that at the 100 level, the tutorial that teaches you how to retrieve single alerts, you can retrieve them in the Avro format, which I mentioned before is like the native format for the alert packets, or you can retrieve them in JSON format or in FITS format. So if you have a preference for how you like your alerts to be retrieved, you can pick your format here. It teaches you how to do all of these things in each of these formats. But what I want to skip to is, so I'm retrieving the full format. It kind of shows you how. So right now, if you do want to make a light curve where the detections are colored by the filter, then the notebook aspect is the tool that you'll need to be using until we get that fixed in the portal aspect. So here you can see that, right, it didn't, this particular object didn't just get suddenly a lot brighter. This is in a different filter. And then you can also pull over the image stamps and plot them yourself if you want to rescale them or measure different things from them. You can get at that data. The other thing I want to mention before we end for the day is in the 200 level tutorial that's all about the alert packet contents themselves. This particular notebook teaches you how to retrieve the packets and then do more with them. If you want just the schema for the alert packets, for example, you can pull that out. There's multiple different records that are stored in there, and it goes through each one. So how to pull out like the associated DI object record, do things with it. If the alert that you've retrieved is for, whether it's for a static sky object or a moving object, different parts of the alert packet will be populated or not. So the records for the MPC orbit or the solar system orbit will be populated if it was associated with a moving object. This tutorial shows you how to get that information out instead. And then the light curves and image stamps, it does that. But that's really the part that I wanted to just make you aware of, that working through this tutorial will teach you the key columns and especially how alert packets for static sky objects are different from alert packet contents for moving objects. They just have different source records within them populated with different information that you would need depending on what kind of object it is. So these tutorials are there for you to work through kind of on your own time as needed. And that's mostly what I wanted to cover. I think there are, right, I wanted to make the note that there are two other prompt-related tutorials that I think you might be interested in, and they're both tutorial notebooks, and they are both under the commissioning folder. So under tutorials, commissioning is where we are holding sort of special temporary tutorials that interact with commissioning data to hold us through until the time when that actually comes out as a released data product, like as the prompt products database. So there is one tutorial there, LSSTCam visits database, that lets you interact with the visits metadata for every LSSTCam image that's ever been taken. This is from April of 2025 up until June of 2026. We've made a special file that has all of the image metadata for everything. So not just images that went into DP2, but all of them, the images that have been used for alert production so far since February. If you need to interact with that image metadata, that file now exists. And then there's another tutorial for the Rubin schedule viewer. So if you are here as a time domain scientist and you're running a live sort of follow-up program and you need to know what Rubin is going to observe tonight or over the next 2 nights, like what the predicted schedule is, then this tutorial for the Rubin scheduler viewer will show you how to interact to get a copy of the future predicted schedule and interact with it so that you can plan your observations if you need to. So I think that covers all of the prompt related tutorials that are out there for you. And I'll just leave you with a reminder to fill out our exit survey and take any questions about prompt products.